Now, referring to page 28, I would first take a look at my coefficients. Are they the same or different? Different. Different. Do they have a GCF? Nope. No. I'm in that unfortunate situation that I have nothing in common, so what I simply do is multiply them by each other. I can choose to either eliminate my x's or my y's. It's kind of the same. It doesn't matter. So I'm just going to go ahead and go with my x's. So since this says 5, I'm going to multiply the top one by 5. Now I already noticed that this is a positive 7 and this is a negative 5. I don't need to multiply by a negative. They will already eliminate. And since this is a 7, I'm going to multiply this bottom one by 7. And let's go ahead and distribute out to all three terms, giving me 35x minus 15y is equal to 340, and distribute my 7 to give me negative 35 plus 56 is equal to negative 791. And let's just add straight down, aka combine my like terms, and you'll notice the name of the game is elimination, and my x's eliminate, leaving me with 41y is equal to negative 451. And let's go ahead and divide by 41, leaving me with y is equal to negative 11, which was really quite simple in comparison to what we had done before. Now, this is where I think some people get confused. Once I have this y value, I can look at either one of these equations and put it into the original equation, either this one or that one. I saw a lot of weird things happening from this point. So I see this one up here is kind of small, so I'm going to substitute y into the first equation and we'll just solve for x by distributing and then removing my constant and dividing by 7, leaving me with x is equal to 5. Of course, you want to go back and double check your answers by substituting back in. And I did the lazy way. I just went ahead and put my 5s and my negative 11s. That gives me 35 plus 33 does give me 68. And then I have negative 5 times 5, negative 25, and 8 times negative 11, negative 88. This one checks as well. Final answer should look like a coordinate. If it does not look like a coordinate, yes, I will take off point. Now, by showing you both substitution and elimination, yes, you'll notice elimination was a lot easier. That's not always the case. Sometimes substitution is easier. Sometimes graphing is easier. You have to make that choice on your own. Number 17. You can use page 29 to assist you. Remember, get your absolute value bars alone. Now you'll notice I have something on the outside, in front, and behind it. So first, let's remove my constant, then remove my coefficient. Now that my absolute value bars are alone, I can split into my negative and positive versions and solve. I would remove my constant. And since x is being divided by 2, the inverse operation would be multiply by 2, leaving me with x is equal to negative 8 here. And I'm going to repeat the same steps by removing the constant and also multiplying by 2, leaving me with x is equal to negative 4. Now, it is imperative to check your answers on this one. Absolutely. So I'm just going to use my erasable pen and put in negative 8. And that would give me negative 4 plus 3 inside of the absolute value bars, which is actually going to give me negative 1. So the absolute value of negative 1 is just 1. 4 plus 1 is 5. Okay, so that one checks. And let's go ahead and replace this with a negative 4. So negative 4, that's negative 2 plus 3. That's 1 again, and so this one checks as well. My solution set would look like negative 8, comma, negative 4. And as you heard, that bell is ringing, so I'll go ahead and stop here.